Welcome to another episode of Learning Live with AWS and HashiCorp. Although I know some of you have been following along, just want to go ahead and reintroduce ourselves. So Jenna, how about you take it away?
Hi, I'm Jenna Pederson. I am a developer advocate at Amazon Web Services, and I am delighted to be here today again to hang out with you and write some code.
Yeah, it's gonna be a fun one. And I'm Cole Morrison, developer advocate at HashiCorp. So if you've been following along, this is episode 3 in a series we're doing where we're building out a microservices architecture. And we're doing it in sort of 2 parts here. The first part being without a service mesh, and the second part, which we're going to actually be getting to very soon, building out with a service mesh. And so just to give everyone, get the feet under their ground, I did want to kind of do a recap, right? So what I'm going to do here is share my screen with our architecture diagram, and I'm going to also ask Jenna to chime in as well, but let me play the screen share game, which is always a fun game. Okay, here we go. Alrighty. Let me see here.
Okay,
well, Jenna, while I'm doing this up, why don't you talk about,
yeah.
I just wanted to do like a recap of where we're going and what we've been doing.
You want me to do the recap, or are you doing the recap?
Oh, go for it. I'm just trying to get the picture up so we can have a visual.
First of all, I just want to say thank you all for joining us today, and I'd love to know where you're joining from. So drop in where you're coming from. I'm here in Minnesota. It's a little bit frosty out there today. Actually, it's warming up, so it's not too terrible. Cole, I know you're in sunny California.
I am. It is. It's I've got the door open, everything. It's a little toasty. What is it actually? Go ahead.
Go ahead.
I was gonna say, could I get you to share it? For some reason, StreamYard is not letting me share this this thing here. Let me try something else. Maybe this will do it.
Yes, it's in this. Here we go. If you share my screen, I can show it. This one.
Yes.
Terrible. Hang on.
Yeah. I think you can just open a new tab, open image in new tab. If you just right click on it.
Oh, yeah, good idea.
Yeah, there you go. Now look at all these people from all over the world.
Yeah.
Yeah, it is.
I'm sure Seattle, nice. Belgium, Bulgaria. Thank you all for being here.
And I'm doing this thing where, like, you know, you read some of the places and it's like, you know, I've never tried to pronounce Monmouth. I'm probably botching that. That's probably not how you say it at all. But hello, for those of you in the UK. Yes, so here we are. This is what we've been working on while we have people chiming in and telling us where they're all from. And what we've gotten so far is we have made all of this except the back part here, the colored pieces. Those are what we're missing, right? So what we've done is we've created a client. We've created a network, a virtual private cloud on AWS. We've created an application load balancer, an ECS service and cluster, and all the things required. And so we've got that client service up and going to where we can ping it, but now we want to connect it to some services in the back and a database ultimately. And so that's going to be what we're covering today. And again, we're doing this all without a service mesh right now. So what you're seeing right here is exactly where we're headed to. And once we get past this, we are at the end going to cover why and what we're going to move to next. So what are your thoughts on all of this, Jenna?
Yeah, I'm looking forward to actually adding in these private services that we've talked about, because I think this is going to be the piece that like really rounds out the functional aspects of what we're building, and allows us to actually get the fruits and get the vegetables. If you haven't noticed, we're building a fruits and vegetables service architecture here. One thing before I hand it back that I want to mention is this is a live stream. We're live. We're gonna make some mistakes.
Oh yeah.
Like yeah, it's going to happen. But also we want to make sure that we get questions from you, and can answer your questions. And if we have to, we'll go off on tangents. So this is about what you need, in relation to what we're building here today. We're not going to go, into like a completely different tangent that's, about something totally different. But we will have a survey, and that I'll show a couple times throughout our show today, where you can provide feedback on what else you would like to see outside of what we're building. And that'll help us shape other, whether it's this show later on as we're doing other episodes, or other content that we build for you. So keep that in mind as we're going through all this, that this is not just Cole and me talking at the camera, because that would be really boring. We really want to talk with you. So please throw your questions out there. We'll have a few questions for you here and there as well. And yeah.
Yeah, sweet. Going on with the survey thing, last time we did some giveaways for some HashiCorp swag. We did this sort of social media thing, and we're just recognizing that not everyone necessarily wants to do that. Instead, for today, if we just see some outstanding participation in the chat or on social media, whatever medium it is, we will pick you and you will just get some swag. So that, just look forward to that. But I didn't want to add that to the extra pauses and stuff, because quite frankly, getting the survey out there, getting your feedback is arguably more important than getting free swag. Or is it? No, it is.
I don't know. I like those free t-shirts.
Yeah. But just answering some of these questions, like, yes, console is going to be the service mesh we're going to ultimately look at. And are we using Vault today? No, we are not going to be dealing with anything secrets management. And yes, happy St. Patrick's Day.
Oh, yeah.
I forgot to wear green.
I tried,
darn
but I don't have green. So
you
got blue today.
Yeah. Darn it. But we do have a green on the screen here. And the colored pieces on this screen are exactly what we're going to be making. The services themselves and their associated task definitions, their application load balancers, and their databases. Now, if you've been following along, you're going to say, well, and this is kind of a repeat of what we've done. To an extent, it is going to be a repeat. The differences being that the ECS client service that we've created so far is public. It's accessible by the public. And the ones we're going to stand up today are the fruits in the service. They are private. They're only going to be accessible within our network, which is an important distinction and something that you're going to need if you're building out pretty much any architecture. And the final thing where we will hit some new stuff is connecting to a database. Now, this is going to be an interesting pattern that's going to set us up for service mesh, because what we're doing so far is we're launching everything in context of our ECS cluster in Fargate and on containers. But what we're going to do here at the end is we're going to launch a fake database. It is not going to be a real database. It's just going to be another fake service, but it's going to be on a raw VM, on an EC2 instance. So it will not be in a container, but we're going to show how those things are all still connected and how to set them up. So any thoughts on that long wall of text I just blurted out there?
No, I think, I mean, I feel like we're pretty close to being ready to go.
Yeah, for sure.
One thing, there was a question in the chat about where the previous episodes are. So you'll be able to find, I did drop a link to them. You'll be able to find those on the HashiCorp YouTube channel. There is a playlist out there. That's what the link is to. When we're done here, Cole will work his magic on this episode, and then within about a day or so, this one will be up too. So if you can't stick around for the whole time today, you'll be able to find it there when we're done.
Yeah, thank you for that. I almost skipped right past that. Yeah. Yeah, and so just I guess the thing to know is that this is going to be kind of the ending part of our first chapter here. So that's going to be something to look forward to. And the second part is just from the 50,000 foot view. We are doing this so that you can front a service to a user, but behind that service have a variety of other services split up. That way you're not monolithing your development process. Now we can talk about more at the end, but I just, it's easy to get lost in the code sometimes. But anyhow, What tool was used to create the diagram, asks Jeremy Myers, and that is Cloudcraft. Cloudcraft, that is a wonderful crutch for those of us that can't even draw cubes, right? So, yeah. Okay, so why don't we go ahead and crack open the code and just talk a little bit about what we did last time before we get into it. What do you think about that, Jenna?
Yeah. So
right.
I have everything. I have my code repo here. If I need to bump up the font, please let me know.
Actually, looks pretty good.
Okay. Yeah. So last time we were here, we did a lot of work in mostly in these 4 files. Creating our cluster, the client service, task definition, and the load balancer for it.
Mm-hmm. Yeah, that is pretty much it. And I feel like it would warrant a greater recap if we weren't going to indirectly recap it as we do this next part, right?
Yeah.
So for those of you like, oh, I want to know everything that happened last time, don't worry, you're going to kind of get to see it here. So the first thing we're going to do then is we can go ahead and restand things back up, right? Because so we should probably do a Terraform apply here. And this is going to take what we've already created and go ahead and stand it back up on AWS. And again, if you're looking for the prerequisites to getting started with this and deploying it, make sure you take a look at the repo, which let me get the link for it here. Go this into here. This is the repo. I'll just put the comment up here that you can, it's got all the instructions of everything, all the prerequisites you need to get it up. And it's really not that much. But again, if you need more insight into that, go check out the first episode. But while we get to spin that up, the first thing we're going to make is that fruit private service. This is going to be a service that sits in our private subnet. It's going to be contacted by the client service itself over another load balancer, and that's going to be our first task. Now, in terms of getting started here, just to go ahead and give you an idea of the order in which we're going to do this, the first thing we're going to do, just like last time, is we're going to define a task definition to go ahead and say what our containers need, what they're going to be. Then we're going to define the service itself, which is going to take the task definition and turn it into containers for us and keep them alive. And then we're going to create the load balancer to connect the load balancer, not to connect the load balancer, obviously we're doing that, but to front those containers of the service so that we can direct traffic to them, and all the security groups in between. So nothing too crazy here. I guess we can go ahead and get into it. I feel like we're sort of jumping in today, like we've said all of the usual boilerplate stuff. So
are there, as we get started, so I'm going to let this keep running, but as we get started, if there are any questions about what we're doing, definitely, throw them into chat and we can pause here. So I'm going to let that run. And then I think we did share the repo. But we'll do that again. I think I can do that into LinkedIn.
Yep. And I also saw Jeremy Myers, or not Jeremy Myers, another user here asked, can we make an HTTPS example? I'm guessing you mean having the load balancer endpoint that we contact as a user be HTTPS fronted. I'd be more than happy to look at that in the future, but the reason that it's not in this first one is because to do it simply in the right way, we would need to include a domain name, which is not hard by any means. We can do that in Route 53, Route 53, however you say the word route. And it's very easy to hook those up to application load balancers, but it's kind of a bit of a side quest to our main story here. But I'll ask Jenna about it and we can see what we can do. So let's go ahead and hop in here. So let's go ahead and start on this task definition, shall we?
Yeah.
Terraform apply seems to be taking its time, but I trust that it'll go up. And if it doesn't, we'll 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 deal with that.
Stuck with it isn't working.
Yeah. So looking at this task definition, I'm going to just go ahead and tell you right now, we're going to need something almost identical to this because we are using a fake service thing that stands up a fake service. So for this first new service, I'm going to assume that you as the audience have followed through episode 2. Here you are in episode 3. You know what we did for this. This defined everything that our fake client container needed. We need to do this whole thing again, except just for this fruit. So how do you want to go about this, Jenna? Do you want to copy paste it or do you want to retype it? What do you think is a good flow here?
I don't know about you all, but if I only have to change a couple of things, I'm going to copy and paste it. I feel like that will be the best experience for all of you at home as well. So you don't have to watch me like go through the keyboard. So I'm going to do the copy and paste approach.
That sounds good to me.
Which did not just happen. So we've got our client one, and now I just created a new one that we're going to name fruits. And I'm going to update a few things here, make sure our tag, the family name is right.
So, yep. So how we refer to this task definition. And those are all the same. I think the cool thing about requires compatibilities is we could have that as both EC2 and Fargate. And there's nothing keeping this from running an EC2, but we're just being very explicit in what this one goes to. So we just have it set to Fargate.
Okay.
Yep. And
fake service image.
Let's rename the name probably under the line 52.
Oh, yeah.
That actually doesn't matter. We can actually leave that as client, but probably just for readability. But yep. So we're using fake service and these port mappings. This is just where it's going to listen for by default. So 9090. And we've got a note here next to 9090 for this host port, but for Fargate, we do have to say the actual port that we're going to be going to. Otherwise on EC2, it just binds to one of those ephemeral port ranges, but that's probably not a topic for now. But as you were, Jenna, apologies for interrupting.
No, that's okay. So we're going to leave these ports the same, right?
Mm-hmm.
Is the 9090 the fake, what fake service is expecting?
Mm-hmm. Yep, okay. It is. Got it. And we'll actually see that change and how to change that when we make the fake database. Yeah.
Okay.
All right. Okay, so nothing too crazy there, right? If you went through with us with the client service, all of this should be pretty straightforward. So the next part then is going to be, well, what takes this task definition, does stuff with it? Well, if we recall, that is our service. So that is probably where we should go next. Yeah, I think so. And for this is going to pretty much look the same too, right, Jenna? Yeah. Which is going to, of course, bring up the question of well, how do we make this private? Well, we're going to make this private when it comes to both the load balancer itself and the network configuration. But the service that's going to take our fruits task definition and turn it containers is going to largely be the same. So what would you like to do here, Jenna? Would you like to do a copy paste, or would you like to type through parts if you want to cover pieces of it again?
I'm just looking through just to see what's going to change. I think initially we're not going to have this network configuration, right?
Right. We're going to have to go make this is going to be the Wikipedia thing. We're going to have to go make the target groups and load balancers and the like. So we can just sort of do it iteratively as well, sort of kind of like a middle ground.
Yeah, I think I'm going to start by copying and then we'll add that one in when we get to it.
That sounds like a good idea. Yeah, that way we can stay on focus. So
root service.
Mm-hmm.
What were you going to say?
Oh, I was nothing. I was going to ask you what you were going to say.
Okay, and so now here we need to use the fruits task definition. So this is the task definition that we just created. We're referring to that. based off of the name, fruits, and then the ARN for that.
Yep,
And
that's
launch
exactly
type
it.
Fargate, and then our load balancer. Okay, so now do we need to go back into our load balancers?
Yep. Yeah. So yeah, this looks good. We can go ahead and we can either optimistically just go ahead and name this target group, what we're going to call it.
Okay.
So we call it like fruits ALB targets, which is probably what we'll go for. And
Okay.
then just sort of do the test driven development approach where we go and make it. But yeah, this all looks exactly like it's going to be.
Okay.
Yeah. So now that means we need to go over to the load balancers. So there are a couple questions in chat I do see, and I do want to talk about. The first question was around was the lock.hcl versus the required versions block. Don't they do the same thing? They enforce the specific version of the provider used. It does, but I guess I like kind of drawing an analogy. That analogy being to something like the Node Package Manager NPM, which is, I feel like, a common one most people at least familiar with. You define your dependencies and their versions inside of your entry, not your entry point, but your package JSON. But you also get the package lock, right? And that package lock being there to help enforce those dependencies down on a deeper level. Now, admittedly, why do we have different things for it? It's a good question. It's a little bit. I don't exactly have a straightforward answer, but I am going to post the docs here on the dependency lock file, just so that can be looked into deeper if you want a longer answer there. And then the second one, and let me just go ahead and highlight that question real quick that we just asked, and I just posted the docs to that in the chat. The second answer, unfortunately, LinkedIn is anonymizing the name here. So we just see that from LinkedIn user, what kind of setup in AWS would you recommend to limit incoming traffic to prevent DOS attacks? So I'm guessing that's DDoS attacks, not DOS attacks from like MS-DOS. That'd be interesting. But so WAF, API gateway, or something else. This is an interesting question. And Jenna, you may have more insight onto that. But my understanding is that if you are on an application load balancer, and in fact, if you're having any traffic incoming to AWS in general, you're going to get a level of DDoS protection in like just by default. Is that correct?
I actually don't know that answer.
Okay.
I just was doing a little bit of research myself to see if I could find some good references for you. I do think the combination of API gateway plus the web application firewall is one approach. There are going to be some. Yeah, I'm going to leave it at that and find a better answer for you because I don't have it off the top of my head.
That's always the interesting part of live streaming when people ask you a question and you're like, I don't know the answer to this. Yeah. Because I don't either. I honestly don't know. But I do. Isn't there the Shield service as well? I think helps with that. I can't recall. There's so many Shield icons in my head when I'm thinking. I'm getting all mixed up. Yeah. Good question though. Hopefully we can have someone chime into chat that knows. But for our purposes, which you've got here with our load balancer, I'm like 60-70% sure, probably a little bit higher than that you got DDoS protection on a certain level, just because you're using one of these Amazon fronted entry points into their infrastructure. But I could be wrong. Anyhow, where were we here? We finished up the service and now it is on to the load balancer. Okay, so with this load balancer here, we are going to be creating another one. And you might say, oh man, another one. Well, it's just the way that it goes. If you're going to have multiple of a service, you need something to help delegate incoming traffic to the various versions, not versions of the service, the various replicas. That's not the correct word for it either, but the various containers that you have that are hosting the same service. And that's what we need the load balancer again. So we did this for the client one, and now we need to do this for the private one. And again, we haven't gone deep into the load balancer, so we're going to kind of stick with that here because they're a pretty well covered topic. And in general, what we're going to do is copy and paste this and modify it again, if that's okay with you, Jenna.
Yeah. So now we've got a load balancer, we've got the target groups, and we've got
The listener.
the listeners. So are we copying one of each, I assume?
Yep. Okay. We're going to need every single one of them.
I'm just going to do that.
Yeah. And so why don't we go ahead and change like what we definitely know needs to change, right? So probably want to change the name. And then for the name prefix, we should probably change that too. Yeah, there we go. I like that. And by the way, that's because there's a 6-character length on the name prefix. So yeah. Otherwise, I would call that something longer, but I mean, I think that works.
Yep, that works.
So here again, we were facing this. We don't have this security group yet, but we're going to go ahead and optimistically name it and with a promise that we're going to go and create it later. And here's where our first thing is going to change around what makes this private. This is public, but well, there's other things that are making it public, but one of the first changes here is instead of deploying the load balancer nodes into our public subnet, we are going to deploy them into our private subnet. This is going to help them be only available back there. Yep. And the other thing is we need to get rid of the dual stack. And this is the setting that gives it both an IPv6 and an IPv4 address. Well, IPv6 is public by default, so we don't want that. And instead, we're going to replace it with an argument called internal equals true.
So get rid of the whole line?
Yep. Get rid of the whole line. And then just true. Yeah. And this is going to tell it that it should not get a public DNS. It should not get a public IP address. It is absolutely meant to just be private. All right. Okay. And other than changing the names of stuff from client to fruits, that is actually all we need to do to make that load balancer private. So now we get to go through those things. Yeah. And while you're doing that, I'm just going to call out a few comments here. People have called out Shield. AWS Shield is a standard that provides basic DDoS. WAF is a good something good to add in front of your application load balancer. I'll just give some credit where it's due here to Fernando. And then we've got some other people have chimed in around Route 53 and AWS Shield and AWS Shield plus WAF. So you're pretty much on the money, Jenna.
Yeah, no, thank you all for chiming in. That is what we're all here for. I'm learning stuff along with you, so thank you.
Yeah.
All right. So we've got our target group.
Yep.
Fruits ALB target group. We'll change this to FR. Leave the port. Leave the protocol.
Yep. And again, just as a recap for these resources while Jenna does this, the load balancer itself is what you think it is. It deploys those nodes. It accepts traffic. The target group is the little pool. So you can almost think of it like a placeholder where we're going to drop in the things we want to send traffic to from the load balancer. And then this listener is, well, where what port the load balancer is going to listen on and what action it's going to take when traffic comes in. And the action we're going to give it here is to forward it to any targets within our target group. Now, again, for me, when I first came into it was like, where are the targets? Like, how are we putting targets into the pool here? Well, when we connect this to the service, that's what the ECS service is going to take care of us. It's going to take care of creating those containers, putting them into that target group so that the load balancer knows where to take them to. Okay. I think this looks good. Yeah.
I didn't really have to change anything with those, right? Other than naming things.
Yeah. Other than naming it is all the same. And I know that's kind of a boring. It's like, oh, and there's not new stuff. There's really not, right? I mean, we're just adding more stuff to get that done. Okay, so that takes us to, let's go ahead and go down our hole here. We went ahead and made a promise here in line 50 to create the security group for the application load balancer. And so why don't we go ahead and do that next? What do you say?
Yeah.
All right. So when we set up the application load balancer for the client, all we did, it was very simple. We just had two rules, right? Allow any traffic from on port 80 from anywhere, and then also allow any traffic to go outbound. And this is actually identical to what we need for this one. Now, let me double check something here while I look that up.
I feel like we're doing a lot of copying and pasting here.
Yeah.
We're going to talk about this later, aren't we?
Yeah, well, we are going to change one thing here
Yeah.
to make this private, but let's go ahead and copy what we have for this first one. And we'll point out what's making this public and how to lock it down. And we can, so we'll just do, sorry, go ahead.
The ALB stuff, right?
Yeah, just the ALB stuff.
Okay.
Yeah, nice. So for this first one, nothing's going to change other than just that we're referencing fruits, right? So pretty simple. And yeah, there we go. And for those of you that are like, but you know, this seems like, you know, a lot of extra stuff. Just understand that if you're doing this in ClickOps, you know, you'd be clicking all this stuff again. And if you're using another infrastructure as code tool, you're still going to be taking the same pattern. You're still going to be making different security groups by changing code. And unless you really feel like typing it all again, there's not really a point. So Command C, Command V still reigns as an amazing superpower. You know, there's times that I'm writing with a pencil and I'm just like, this, if only I could copy paste, right? Like this just feels so primitive. Anyhow, yes. So what the change for this one is right now that allow 80 is actually public in the sense that we're saying, where are we allowing traffic from? We're allowing it from the CIDR block that is the representative of anywhere. And we do not want that. We want to lock this down. And what do we want to lock it down to? Well, in our architecture diagram, we are saying that the only client services should be coming to this. And so what we're going to do is we're going to eliminate the CIDR block and IPv6 CIDR block fields altogether. So we can actually just straight up delete those. Yep. And there is another attribute that we can add called source security group ID. And hopefully the auto completion comes up here. Yeah, there it is.
There it is.
Yeah, there we go. Yeah. And we're going to change this one to the ECS client service security group that we've already made below. So we'll just...
I do not know what just happened. I really don't know what just happened. It's like comparing or something. Hang on. There we go.
Oh, there we go. I was like, I've never seen that screen before.
I've not seen that view either.
Yeah.
Okay, so what I'm going to change. I'm going to set this to...
Yes.
Just there. Group?
So we're going to, so the AWS security group. Got to give the resource type.
Oh, that's right. Thank you.
And then and then we just end that with .id.
Okay.
Yeah. And so what this security group rule is saying now is it's saying that if you're fronted by the security group ECS client service, then you can, then we're going to allow traffic in from you on port 80. So that's exactly what that's saying there. And suddenly that helps make it private, right? So this is kind of where we'll see a little bit more, but in essence, these small changes are what have made it private. We actually created the ability to make stuff private from the get-go. And it's began when we created that VPC. When we segmented it off part of the VPC to be private subnets, we didn't allow access to an internet gateway. And here we're just taking advantage of that by pointing to those things, by using the security groups and then those small changes to the load balancers. So I like pointing that out because it just says when you're making an architecture, you really do have to think up front, right? Because this decision wouldn't be possible had we not thought that up at the beginning. All right, so that finishes the load balancer security group. So what we've done so far is we've made the new task definition that is for the service. It was identical the service, the load balancer, which is internal strictly, so it's just going to be private, and now the security group to only allow it from clients. So now we need to go back to that service, I believe. Yes, and now we have fulfilled our promise of this target group, assuming assuming no typos, right?
Yep.
Any thoughts so far, Jenna?
Not yet. I mean, there's some copying and pasting happening, but it's like I said, it's better than the click ops.
Yeah.
last time.
Yeah, for sure. Well, that takes us to the network configuration block next, right?
Okay.
Yeah.
So we're adding one of these in.
Mm-hmm. Yep. And this is going to stay the same. These first two are going to stay the same. And the only thing that's going to change is we're going to need to go and make a new security group.
Okay.
Yeah. So there's something that while she types that out that I have wondered was well, wait, this is the subnets it's being deployed to are already private. Like why is that other service clients public, but it's still in the private subnet? Well, what makes the other one public despite the containers being deployed in the private one is that, again, they're fronted by a public load balancer, which is why that is what's actually making them public. If that didn't make any sense, just call me out in chat. I'd be like, yo, Cole, I don't know what you just said. Repeat yourself, and I will do so. Okay. So this takes us to security groups.
Security groups again.
Yeah.
So we're going to do this. Well, okay. Let me just see if I'm following.
Yeah, absolutely.
That we're going to create a security group called ECS Fruit Service. It's going to be similar to this one.
Yep.
Okay.
You're dead on.
Do I need all of this?
Mm-hmm.
Okay. So we'll call this Fruit Service.
Mm-hmm. The fun of
yes.
But I mean, you think about it, this is still a large percentage less of typing, right? Than if we type it all in.
And I think there's a lot of boilerplate code here, which
is almost inevitable. And I just want to touch on, because nothing in this one is going to change as she types it out. We're not changing anything other than the names. So the question might be, well, why are we even making this? Why not just reuse the other security group? And you can choose to do that. This is really it. There's also some other options that you can go about doing it. It just comes down to, I'll be honest, a little bit of a preference and forward looking. If you believe that this service is going to require different rules that are from other ones, this is going to be a good place to go and set up this foundation here so that later you don't have to go back and look at it. And also we had a techie thought here on Twitch mention maybe a dynamic block, and that is absolutely an option. Dynamic blocks, we can add in for loops for those different things and generate them dynamically. Okay. However, with security group rules, with stuff, I tend to like to be more specific. You know, that's just my preference. But sure. Whether it's right or not is different. But it looks like you got it all up. Yeah.
I think so.
Right. Yeah. Yeah.
Okay, so we only have 2 services here.
Mm-hmm.
What happens if we have okay, I have a question for the audience.
Mm-hmm.
If you're running an architecture like this, how many services do you have? Do you own? Do you have to manage? Is it 10? Is it hundreds? Throw your answer in chat if you're doing this. And if you're not, that's cool too. Maybe you have a monolith and you're talking about moving towards an approach like this. So I'm interested in understanding where people are at in their in how they're running their workloads right now and how their architecture looks. So if
That
you
is a
have,
great idea.
yeah, if you, yeah, please let us know in the chat. We'd love to hear this, because where I'm going is like, this is only 2 services, and this is a lot for 2 services. A lot of kind of the same code, boilerplate code. What happens when we have hundreds of these?
Mm-hmm.
And then I have a team of 100 people or 50 people that also have to work on this. So
Mm-hmm.
we'll talk about that in a little bit, but as I'm going through this, that is definitely something I'm looking at.
Yeah, I would love to know as well, people, that if you have, if you're on a microservices architecture, you just chime in. That'd be great. So while we wait on answers for that, if those come, if not, I will say, for those of you looking for a more scalable pattern that perhaps remains specific while not using loops and the like, at certain points, you'll start carving out common functionality that your various services need, and you'll start kind of thinking them almost like AWS makes you think about IAM, right? Like, what permissions and ports does a particular service need, and creating an archetype for each of those services, and each of those archetypes getting their own security group. So we have another person chiming in that they had a product with 50 to 60 microservices, and that they're currently on a common SaaS platform having just 5 to 10. And we had Fernando chime in here that they've got 10 plus services, but they've got them modularized to avoid the repetition of common blocks. And from the previous one, we had a techie thought also follow up his thought with simplify it by creating a service template and driving things by simple conventions. Also a fabulous idea. And then we had Jeremy Myers tune in. So as the infrastructure team, we own the VPC and control the security groups. We lay that out for the app team. They can deploy as many apps on that VPC. Same for load balancer, 1 or a few total owned, maintained by the infrastructure team. And then another LinkedIn user that we've got upwards of 16 different types of services, multiple instances of many of the tasks running, and then multiple instances in different regions. So a lot of stuff. Great.
Good.
Thank you for chiming in.
Exactly. Yeah. Thank you so much. That's helpful for us to understand, like, what types of problems you might be encountering. So thanks.
Yeah. And a good question, Jenna. Very good.
It's actually been on my list for all 3 episodes, and this was like the perfect timing for it. So
yeah. Well, for those of you that have chimed in, if there are any advanced stuff that you'd like to see in the future, or any nuggets of wisdom that you might have, feel free to throw those in. But okay, so we've got this next security group in place. And as far as what needs to happen next, well, now since we're done here, we can head back over to services. I believe, everything looks good there. And we don't need to change anything here because that's actually been done. And yes, let's see. Oh, we do have one more thing to do. We have actually completed everything we need for this fruit service. So despite the fact that the last episode took us like an hour to get through that, this time we're already done with it. But for what we need to do now is tell our client service to try and connect to this one upstream. So what we're going to do is head over to our task definition. So over to here, and under our environment variables for the client, we're going to add a brand new one. So we can just copy paste that and just change message. You just use that as like a template. And we need to change this to upstream URIs. So upstream URIs, and this is an option you can pass the fake service, and you give it URIs, and it will call up to those and include that payload here. And we'll see how that works here once we deploy these changes. But what we need to do here is give it an HTTP resource to reach out to. So we're going to use some string interpolation to do this. So we're going to do HTTP, that whole boilerplate stuff. And then we're going to actually give it the DNS of our Fruits application load balancer. So to do that, we're going to need to grab its attribute. And let me send you the docs here for that, since I, for some reason, cannot screen share all.
Are we these docs?
Sorry. Do you have, just search for load balancer.
Yeah.
This will be faster than me trying to, and then do the V2 load balancing V2. It's the second category. Yeah, there we go. And then the AWS LB right there. Yep. And then if we go to attributes, so just on the side navigation, just down to attributes, these are the things we can get back. And what we need to get back is that DNS name.
Okay.
Yeah. So
Okay,
to do, yeah.
I'm gonna go back to this, and I can't remember. Oh, it's $ curly bracket.
Yep.
And
That's it.
I need to reference the type, resource type.
Mm-hmm.
I'm gonna actually go look because I don't really know.
Yep.
And then we're doing the fruits.
Yep.
That one.
Yep, that's dead on.
And then
Yep.
DNS name. Oops.
Perfect. Yep, that was it.
That's it.
And yeah, that's actually all we need for there. So.
And we don't need any ports or anything like that because we have all the stuff forwarding correctly.
We do. Okay. When it goes to reach up to that, because this task definition will be under a service that is allowed by the Fruits application load balancer, it will be able to contact it.
Okay.
So now we are ready to apply what we have done.
Okay. Should we do a Terraform plan first?
Sure.
Well, let's start right first.
Yeah. And this will go and make all the things. Now, I guess we can, while we're here, just sort of talk about this state stuff that's happening right here. Something that helped me as we watch this apply here. Actually, we can double check that if you want. I mean, this all looks correct without having looked at. What's it destroying?
Yeah, I'm interested in that one.
Yeah, it's a little fishy. All right, this all looks good so far. Yeah. Forces replacement. Oh, of course, because yeah, that makes sense. We do need a new. We would make that second version. Yeah. Okay.
Wait, I don't get it. So the client task definition.
It's just the task definition.
What?
Go ahead.
The client task definition is getting replaced?
Yeah, it's getting replaced because we added that environment variable, and I believe that this is how it redeploys to the service after the fact.
Got it. Okay. That makes more sense. I forgot about that, even though we did it just like 30 seconds ago.
No, I mean, I'll go.
Okay.
Yeah, there we go. Going through this, something that to talk about this, all the stuff you see going here, this refreshing state. If you're used to working with CloudFormation, you think in a template-based mindset, right? You make a template, you apply it, but if you change something up there, right, it doesn't reflect on the template. You can then go take that template and deploy it elsewhere. Well, Terraform is very one-to-one. What you see in your code is what's up there, and it does it by keeping track of everything that is live on AWS with a state file. And so what you see here when you see refreshing state, what's happening is that Terraform is actually calling up to AWS to get the state of everything that is up there so that it can keep track of, keep that dependency graph on point and make these changes in a way where nothing didn't clutter or the like. So that is what the state file is for. It's a very sensitive file. It has delicate feelings. You should not go sharing its secrets with other people.
And is that, so right now, would that state file be stored locally on my machine?
It is stored locally on your machine. Okay. We can actually see it in the your sidebar. It's that .tf state file. And we've got it get ignored for good reasons. But the point of this state file is when you're collaborating with people, if you want to be on the same infrastructure, you both need the same state file. All right. And so that is where we can talk about collaboration like way down the line. There's obviously the state file is one piece of it, but modularizing, actually someone just said that for large unit production workload, think about having modules version in a private repo. That's an absolute great comment, because that will help this. Because once you start making really, 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 really big Terraform repos, refreshing state can become a longer process than you want. So
Yeah.
yeah.
So a techie thought just mentioned the GraphViz dependency diagram. I need to get that installed locally, because we tried to do that during the first episode and I didn't have all the parts installed. So that is a good reminder. And would help with visualizing some of the stuff that we're building.
Yeah, that is a very good point. It is a very good point. I often will look past that. Yeah, and then someone put up here state file. Fernando put up here that state files are a good discussion topic. Remote backends versus Terraform Cloud, so on and so forth. So I think, Jenna, we planned to take a look at the whole collaboration topic towards the end, because there's not a lot. Yeah, so of the series, not today.
I mean, just to be clear, we're doing a lot of copying and pasting today. So like the code portion, we're gonna get through it here pretty quickly. And then we're talking around kind of our later topic, which is some of these collaboration aspects of like, how do you collaborate with two or more different developers on the same infrastructure with the same Terraform files. So we're going to get there.
Yep, absolutely. And it looks like we are part of the way there. It looks like this is finished.
It was successful.
So why don't we go ahead and just grab that the DNS right there and plop it into the browser and hopefully see that it has worked.
Yeah. So that was an output that we added during the last episode. Towards the end of the last episode, we added that.
Yep.
What's happening here?
So we've got that.
Hang on.
Could you fit your browser to? Yeah, there we go. Interesting. This is not how this should look. Could you type in /UI to the end of it?
I can.
I wonder if it's because the old tasks are still draining. Huh. Okay.
Should we go into our console and take a look around?
Yeah, we should. We should see. We should see the first thing there, but we do not. Yeah. So.
Sorry, ECS.
Yeah.
Okay.
Into there. And into our cluster here. I'll bet you some of them are still. Let's go into the client here. It looks like we've got 2 running. So I bet you one of them still draining. And then just click on the tasks tab. Okay, so now it's inactive. So I'm hoping if we refresh, it should work.
There we go.
Okay. Nice. Okay.
So
here we can
everything is instantaneous, is what we're learning.
Yeah. Darn it. Why isn't Amazon Prime, right? Like, come on.
Yep.
Yeah.
Okay.
Good. So
let me go back to I'm going to go back to and refresh that. So now we can see that the upstream calls the internal fruits service, and it's returning, and it would return hello from the fruits client.
Perfect. And I like that. Yes, our fruits are on the table.
Yes.
Can you grab that internal load balancer and try putting it in your browser?
I can, but I feel like it's not going to work, right? It should not work.
I hope it doesn't work. If it does work, then that'd be really awkward for us.
Yeah.
But it should just hang here. So.
Okay.
Yeah. Which it is. Sweet.
Yeah. Okay. So I'm gonna just stop it because we know it doesn't work.
Yeah.
So I'm gonna ask a quick question. And we don't have to get too far into this at the moment because it's not where we're going today, but you and I talked about this a little bit yesterday.
Mhm.
I'm curious on like my web app, it needs to hit, it's going to hit this client service, right? And I want to get a list of veggies, or I'm sorry, fruits. We're doing the fruits right now. But how would I implement something like that? Is that where this API gateway would come in and we would allow it to route? Or is there some other, or is our client service smart enough to manage that? We just, because we have a fake service here, it's not doing it.
Yeah, this is a really good question. So just for my understanding, let me
Yeah.
clarify for my own
Yep.
understanding here. You're saying that that let's say that you have an external application that wants to say make use of our fruit service, right?
Yeah.
And how right now we can only get into the client.
Right.
So what do we have to do to the client to make it so that we can back in go to that fruit service? Is that what you're asking?
Yeah. Or like maybe our app needs a list of groceries
Hmm?
that we can purchase, and it's going to get both the fruits and the veggies, which we don't
Yeah.
have yet. I understand like how we're going to get them combined together, but how would our, like, in my mind, I'm thinking I should just be able to do this and
Yeah.
add fruits to the URL,
Hmm.
and it routes it to the right service, which it doesn't
Hmm.
do necessarily
Right. Yeah.
yet.
This is a great question. And it's part architecture in the sense that for this particular architecture, our client app is the end user's app, right?
Mhm.
We don't have a unified place to where our API is going, and so we have a fruit service, a vegetable service, so on and so forth, blah 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 blah. So let's just talk about the simple approaches. We'll go from simplest all the way up to most complex. If we believe that our fruit service here, for example, is secure and public ready, right? Then what we
Yep.
could do, the simplest thing is we could just make that internal load balancer public. If we do that, suddenly you would have access to the fruits thing. You would have to hit a different endpoint. Okay, so there is that. The
Yep.
second thing is, well, what if we wanted to do the example you've put in your browser there? Well, that's going to take a little bit more architecture changes in the sense that we're going to have to even front something in front of our client, whether
Right.
that be Route 53 or an API gateway, to catch the DNS upfront and say, okay, based on this URL, what are we going to take things to? And at that point, that is where we could use something like an API gateway or just straight up DNS to start pointing to these different things. Now, if we want fruits public, we would still have to make its load balancer public. That's
Sure.
something that we would still have to do. But both API gateway, Route 53, those are both ways that you could get into those things. And then there's, of course, the simple way where I just said, just make the load balancer a straight up public.
Okay.
Do you
So
want me
in
to
our
go into? Go
no,
ahead.
no, this is perfect. So I just want to kind of recap what we have, which is our client. Today it's a fake service. It does nothing. So we can't actually see that implementation, but it could be a little bit more smart, and um, whether it has to, process some of that data that it gets back from the two services, or it formats it in a certain way. Our web app that doesn't exist would point at this client and get the data that way. However we've defined it.
That's actually that is interesting. That's actually another architecture pattern we could take. We could just straight up take the client and rework it into its own mini API gateway, for example, which is an
Sure.
interesting approach. Yeah. Huh.
There are multiple ways to do it, is what we're getting at.
Yeah. Yeah. Oh, that's actually a good idea. Yeah. Cool.
Yeah.
Nice. Well, that brings us to, and of course, there is the whole service mesh topic, but we can talk about that at the end. Okay.
Yeah.
So what we're going to do now is we're actually, we need some more grounds for experimentation, but just to show you how quick this is going to be, we're going to actually make another private service real quick, just to show that we've got two parallel upstream services. And this will give us just a little bit more of a realistic sandbox to play around in. And so what we're going to do is we're going to make a vegetable service here. And we're going to really speed through this part because it's the exact same thing. So Jenna, would you like to begin our journey to bring vegetables to the people?
Yeah, I'm going to just do a commit to make sure we don't lose anything here.
Good idea.
Okay. We're going to start with the task definition again.
Yep. And we'll just copy paste the whole thing.
Exactly.
Yeah. And the only things that will change will be just from fruits to vegetables.
Okay.
Yeah. Now, again, as she does this, it's like, well, you know, this is a lot of boilerplate. Why is it all the same? Well, it's because we're setting up sample stuff. So realistically, these two services are probably going to be different if these weren't fake services. So we would need to change some of this stuff around. But because these are just straight the same, using the same Docker image, we're returning something false. There's not changes there. We just want this here for the greater architecture so we can kind of focus on that. Okay, cool. This looks good. Yeah.
Okay.
Yeah. Can you scroll up just so I can, I just want you, would you mind scrolling up just a second? Okay, sweet. All right, onwards to the ECS service.
Okay, so here. There's a really good question in the chat, I think.
Oh, yeah, here we go.
While I'm typing this out.
I use JSON or template files for keeping task definitions. So what's the best way to keep your JSON policies or task definitions, etc. in Terraform? You know, that's a good question. By JSON or by task definitions, are you saying that you create a general task definition in, say, JSON or template, and then when you need to pull it into the Terraform code, you just interpolate it in? Or are you, or just if you have any more clarity there, a techie thought? I'll just, before I just proactively begin answering here. And I will post this follow-up on the screen when he adds it.
Okay, so I think I've got, it's going to be the same again, right?
Yep. Yeah, and then
vegetables.
To follow up, he says definitions are general, but I use interpolations also sometimes. Okay, I'm still a little fuzzy on the question, but it seems like the question being that what's the best way to keep okay, I have seen the use of temple into apt factory Terraform code. Yeah, so is this just a general, sorry, just for my clarification, is this just in general things that you want templates for to pull into use? So as you can see, like when we're creating that task definition, we're doing that JSON encode thing. Are you talking about keeping that part separate and then pulling those in? And I'll play the single threaded game and come back over to Jenna. And yes, you are. As far as that goes, I don't have a strong opinion on how you go about doing that. There's whether you use a template file, whether you use a JSON file. I'm not sure that, and I could be wrong, but I'm not sure that has a major impact on anything beyond just what fits your workflow. Right. So for example, in this line 92, where we've got this JSON encode, you could instead just make a JSON version of this and say another folder. Like we have an images folder here. We could have a templates folder, and we could code this out in plain JSON and then just pull this in with our file function, which we'll take a look at those later. You can also just put it right in here if you'd prefer to see it in HCL format as well. Now, as far as it being right or wrong or whatever, I personally like to stay in HCL land. That is just me, and that just comes from the number of like curly brace semicolon arch villains that have like caused me much pain here and there. But there is a lot of flexibility that comes with JSON templates, and that is that you can iterate over them, crunch them up, process them, and do a lot of stuff with them in a much easier way. So if you're going to be doing a lot of processing of any templates you're going to be using, if you're going to be, say, setting up some code to do something to them, it is probably where JSON's going to be a little bit easier for you. But yes. So we've got some other, in fact, I'm going to just go ahead and highlight a good answer here from Rosemary, because she is one of the Jedi masters in our ecosystem. So the general approach is that pulling the JSON in doesn't always give you a diff. It's true. Some AWS resources do have HTML structures, which better show diffs. But if I have a separation of concerns between an application definition and deployment, I do prefer pulling the JSON. It gives a bit more flexibility in terms of volume definitions. And then a follow-up comment: there is nothing more complicated than trying to parse and merge a bunch of volumes into the task definition in Terraform, which is funny because when we start setting up our console modules, we're going to see just that. So, but we'll cross that bridge when we come to it. Thank you, Rosemary. Okay, so thank you for the question also, a techie thought, and thank you for your answer and perspective as well, Jeremy Myers. Stored in a JSON file, then read it in. Yeah, so that's also a great point as well. And I like this syntax highlighting and tabbing. We can look at that as like, oh, but that's just a thing. But the wrong syntax highlighting, the wrong tabbing, that can screw you up, right? So, okay. Did you have any thoughts on that, Jenna? Sorry, that was kind of a Terraform question.
That was good. I think yeah, the answer is going to depend on what your needs are too. So
sweet. Okay, so looks like we've gotten through the service here. So we just need to go do the security group next, and this is going to be identical as well. And so again, while we're doing this, if y'all have any other good questions like that one, feel free to ask, and we're more than happy to go in. Rich Cotters, I feel like a terrible person because I do most of my definitions in YAML and then import them via locals. You're not a terrible person, Mitch. You know, you can like YAML. No, I have no comment, but you can like YAML. Yeah, so we're gonna go through, and while we're on the security groups thing, I suppose we did have that comment earlier about, you know, sprawl of security groups, and we're seeing it here happen as well. In reality, what we could have done for this is we could have, if we wanted this to be shorter, we could have just like made a security group called ECS like private services, and then just used this and attached it to both the vegetables and the fruits load balancer. So that's an option there as well. And we could have done that for the other one, but hey, here we are. So there we go. Nice.
And we're not changing anything there.
I don't think so. I'm just looking over. Yeah, that looks good. We will have to change something in the next one.
Okay. And that next one is going to be the load balancer.
Actually, wait, did we just make the? Yeah, we just made the fruits load balancer one. Yeah. Did we?
Yeah, we did. We've already made the fruits one. Now we need to make the vegetables one.
Oh, I see. Okay, my bad. Yes, yeah. So, yeah, we need to make the vegetables load balancer. What security group did we just make there? Did we make the load balancer security group?
Oh, I see what you're asking. Maybe I did.
We did. Yes. Okay, perfect. That's. Oh, this is the service one.
I made the service one.
Okay, cool. Yeah, the service one we
confused.
Yeah. So just if you're confused, I should probably for everyone, we have the application load balancer ones, which are going to sit in front of the load balancer and determine what can come in through it. Then we have the service ones. So we have the client service one, the fruit service one, the vegetable service one, and those sit in front of the actual service itself. So you have the security group in front of the load balancer, then you have the security group in front of the services themselves, right? So that's what's going to be there.
Okay, so the ones I just created were the service security groups. Yes. So I need to go back and create the load balancer security groups.
Yeah.
Group. Okay.
For the vegetables one, can we look at that? Can we look at the one you just made first though? Because something does need to change in the vegetable service one.
Down here, you mean?
Yes. Yeah, which is Yeah, the source security group there. The source security group ID that needs to be, oh no, never mind. Wait.
We're going to create that in a second.
Yes, that is correct.
I just, for all of you at home, I did this backwards. So, well, not backwards. I just did it differently than the last time. So I'm going to go back and create the vegetables load balancer security group.
Yep.
And then I'll come back to what I just did
Yeah.
to like round that out.
Yes. Perfect. Yep. And we do need to leave that client service one as is, which just is saying, yeah, that the clients can access our vegetables application load balancer.
Okay.
Yep. And then,
so then this security group, vegetables ALB security group, is getting referenced down here.
Yes. Perfect. Yeah.
Okay.
Yeah, because that's saying that our vegetable service is accessible in 9090 by anything with the application load balancer ID, which is what we want.
Okay.
Sweet.
Cool.
All right. With the security groups out of the way, we're actually clear to just copy and paste the rest of the stuff because I think these were now we need to do the load balancer.
Okay.
Yes. And this will be a large copy paste, just switch the tag around. Yeah. Cool. If anyone else has any other questions as we go, feel free to add those in and we will answer them. And so after this, what we're going to have is that parallel private service, and we'll deploy that. So it won't be anything new, but it'll just give us more room for later on when we go and we're trying to link all these things up, because it's kind of hard to demonstrate a service catalog and service mesh when you only have one service. So it'll be helpful later on. But for now, we are just subjecting Jenna to a lot of typing. So
it's all good. What do you say? Repetition is the
mother of skill.
Something like, yeah, that's what you said. Yeah. I've heard you say it before.
Or boredom, one of the two.
Yeah, exactly. Okay, so I think I got that.
Yep. And then you got to compliment Jenna that hats off to your skills. Getting lost in larger files, yes, is a thing. So
they're not that big, but thank you. Okay, so now that we have the load balancer, don't we just have to add it to the? Maybe I'm jumping ahead, but don't we just have to add it in here now? Not.
Did we do the service? I think the service is correct now, right? Yeah, because so as long as those things are all named the same, yep, we are good with that. And you're right, we do just need to add it to that client right there under the upstream URIs. Yep. And we're just going to put
an array. What happens here?
It's actually just a string separated by commas. So just a comma and then the same thing again.
And you know how much I like typing, so I'm going to copy.
Perfect. And we should be good to apply the second one. So we just did that in like what, 10, 15 minutes. So, it's not too bad.
And get into the good habit of doing Terraform plan. I know it shows, but
yeah,
it does show, but I'm going to do it anyways.
Yeah. I'm guilty of skipping it sometimes as well. So we'll do a state refresh here where it's going to just update anything locally, sync it up, and then take a look through here. And I believe this is the same. I'm pretty sure if we scroll to the top that one to destroy is just going to be that updated task definition again. Yeah. Yep. The client. which is what we thought. Cool. So now we shall apply it. So while we wait for it to apply, Jenna, now that we're pretty deep into the Terraform land, I know it's been a bit since you've worked with it. What do you think of it in 2022 so far?
Yeah, you're specifically about Terraform is what
Yeah,
you're
how do you feel about the workflow and stuff?
Yeah, I like the workflow. I'm always interested in what the workflow is going to be with when I work with other people. So I'm interested in like talking about that a little bit. I as far as like the back and forth between like my code and the documentation, like that is I feel like I'm mostly comfortable with that now. I might not always find stuff quickly,
None
but
of us do,
I
right?
kind of understand that flow. I do like one thing, when we first started this, we installed, oh gosh, what is it called? I have so many
The
things
Terraform
installed. We
extension.
installed this, yeah, the Visual Studio Code extension. And I feel like it's very helpful. So I would recommend that if you're getting started and don't have it yet.
Yeah. While we're on that topic, real quick, James Porgan, who's works on the editor experience, so this particular extension and everything, said that if you have any feedback or if anyone has any feedback, he would love to know. And if we wanted more tips or something around using it, he'd be more than happy to oblige.
Cool.
So just something there. But anyhow,
Speaking of feedback, I feel like right now is a prime opportunity while we're waiting for our Terraform apply to work to ask you to fill out our survey. As you know, we both want to take your feedback and feed it back into both this live stream, the show that we're doing together, but also into our products and services that we're building. And we can't do that if we're not getting that feedback from you. So we would very much appreciate anything, constructive thoughts on how we can do better during the show, what you would like to see during the show or during a future show, or what you would like to see with the tools that we're using today. And that VS Code extension would be one of those things that we could take feedback on. For the first 20 people who fill out this survey today, you will get a $25 AWS credit. So
and that's awesome.
We would appreciate that feedback.
Yeah.
Any help we can get.
Yeah. And hey, $25, that is like the perfect amount to set up a, we'll set up a number of
try
things.
This out.
So,
yeah, exactly.
Yeah. So it's every bit helps. Nice. So where are we on our apply here? Well, you can leave that up, the code up.
It's still going.
We can just probably leave that up as we go here.
Yep.
Yeah, and if as Jenna spoke about as well, give us every bit of feedback. We may not, just admittedly, some of the stuff may be out of our wheelhouse. We may not be able to talk about it, and some of it may just be grounds for an entirely different series. I know we had a question about IAM and conditionals around that. What's interesting about that is we originally had some IAM stuff planned for this, but we sort of stepped away from it because it is a large topic, a very large topic. It's a large topic. It's a huge topic. So, but for good reason. It's for good reason. So for topics like that, apologies, we probably won't be able to go as deep in those in this specific series, but knowing that helps both Jenna and myself get ideas for future content. So,
yeah. And on that note, like if there are questions that come up, we very much are going to try to get you, and that we can't answer, we're very much going to try and get you connected to the right people or to the right resources so that you can get those questions answered. So keep that in mind as well. Okay. Also, Mitch Connors is talking about security Twitter, telling him not to scan QR codes. That's really good feedback. That's good to know. I actually
That
have a
is,
link that I can give you.
yeah, that
I don't
works.
know like if you're allowed to click links, but let me, at least you'll know what link you're clicking.
Yeah. If you want to send it to me, I can put up a banner because I know it won't let us output directly to LinkedIn from here.
Yeah.
Although I can just open up LinkedIn and just put it right in the thing.
Yeah. I just put it in the private chat there.
Okay, it's perfect. I will post the link to that survey here in just a second. Let me go to this.
Thank you for calling us out on that.
Yeah, that is helpful to know.
Usually we like to do both, because obviously the QR code is sometimes a little bit easier to click if we don't have the link handy, but yeah. So.
All right.
And then
so
okay, cool.
there we go. That should be posted up everywhere.
Nice. All right.
And it looks like it's up.
We have success. So should we, it's the same client one. So I can just go here.
Mm-hmm.
I'm going to get rid of our, and now
look at that.
We've got, oh, wait. Oh, we do have the vegetables. Yep. And if we want to see the visual UI part of it.
Nice.
This is helpful to see. Cool.
Nice. And if we wanted to just sort of like show off one of the features for ECS, I mean, this should come implied, but if, say, the vegetable service were to go down, it will come back up. Like ECS will put it back up, service will go back up. Do you want to like simulate one of those, or you want to just move on?
Yeah, let's try it. I'm not sure how to do that, but
cool. So we just go to our cluster here and then end up refresh this tasks thing. Actually, no, go back up to the full cluster.
Oops.
Yeah, and then in, and then let's just do the vegetables one. So just click into it.
Oh.
Well, actually, you can just do it from there, I think, too. Then go to tasks. And then click on that task. Well, just do the task, not the task definition, if you would. So the little ID there at the far left. Yeah. Yeah. And then just click stop. Yep. Because on the previous page, it would have just deleted the whole service. But now this will stop the task. Okay. And if we give it a second, what'll happen is we'll see it show up on fake service.
Where should I go look right now?
Let's stay on the, actually, can you scroll up some here? Let's stay on this one and just refresh that little button. Okay, there we go. We see pending. Let's go to the fake service tab real quick and refresh this page. And we should see, yes, so we see that this is down, right? So that's pretty neat. But we already saw as a spoiler in the previous, on the ECS console, that it's already starting to try and spin the next one back up.
Yeah.
So this is the service going back up. Now the client should still be working. So if we want to look at that payload, we can. If you just go to the straight without the UI appended to the end of that URL.
What am I doing? Sorry.
Just delete UI there on that URL and then just go here. Well, it looks like it's already back up. So yeah. So never. It would have just shown an error there under where the vegetables piece is. But if we go back to the ECS console, we should see that the vegetable service is probably already up again. Yes, it is. Okay, so that's just a cool thing to see, right? So if it goes down, it'll come back up. And that's one of the nice things that just comes out of the box with ECS services. So
yeah, we didn't have to do anything there. I noticed there's a question from the one Black Mage on Twitch. If you redeemed an AWS credit from the last session, are we unable to do it for this session? I think you just caught a bug in what I'm doing, or how I've done this. So yes, I think that is actually correct. So I apologize. It's going to only apply to those people who did not get it in a previous one.
Gotcha.
So I'll see if I can get that ironed out for the next episode.
All right. Sorry about that, Black Mage. Okay. Well, that takes us on to our next part, which is setting up this database now. Now, in this part, we are going to encounter some differences. And the big difference is we're not going to be putting this on Fargate. We're going to be putting this on EC2. And we'll let Jenna commit her work here so we don't lose it all. And the way we go about doing this and connecting this, we're going to have some differences here, but we're also going to learn some nice little Terraform and EC2 tricks along the way as well. So why don't we do what we do for this new part and make a new file and just call it EC2. Yeah, perfect. And we're going to create a resource called an AWS instance. Would you mind opening up the docs for that? So yeah. Now, if you've done any Terraform 101 stuff, it should just be AWS instance without EC2.
It is AWS instance?
Yeah, with that, yeah, I know what you mean. I searched for EC2 when I first started this stuff too, but it should be under the EC2 category. Yeah, there it is.
That's why. Okay.
Yeah. I am curious as to why we left out EC2 from it, but is what it is. So if you've done any of the 101 stuff with Terraform, then you've encountered creating an AWS instance. So we're not going to spend too much time on it. But we do have the docs here open for reference, and you can see the example usage here. But did you want to scroll through that, or you want to just hop right into the code, Jenna?
I think we can just hop right in.
Okay, perfect. So let's go ahead and create a new resource in this file. It's going to be the AWS instance.
Oh, I'm not doing anything.
No thing work. There we go. Thank goodness.
Okay.
Here we go, instance, and then just call it database or whatever. Yeah. And let's begin as we begin in the console. The first thing you get asked in the console is for the AMI. So why don't we make that the first argument here? And just we're just going to set that equal to an empty string for now. The reason we're going to leave this empty is because we're going to come back to it. You can hard code the ID of the AMI, and that's absolutely a valid option. But we're going to use the SSM parameter store to grab a latest version, just so y'all can see a nice little trick in working with SSM, which is a terribly useful utility within AWS that I love using. So next, you're usually asked about instance type. And that's going to be our next argument. So instance type. So instance underscore type. And this is again just using that workflow we talked about in episode 1. If you're confused about what fields to focus on, this is how to do it. Use the console as sort of a mental model. Now for this, there are all the different types of EC2 instances. And unfortunately, I do not believe on that page, let me look here, that we have a list of all of these. See here, I don't think that we have a list of these. Yeah, instance type. We do not have a list of the exact strings that you can use, although perhaps, yeah, no, we don't. So you know these or you don't, but they're exactly what Amazon names them, which is so like T2.micro, for example. But why don't we do the T3 micro since we're on the trilogy now. So that's just the instance type. And then the next thing is going to be VPC security group IDs. So it's kind of there's going to be an underscore in between each of those. Yeah, there we go. That's going to be an array or a list, what you want to call it. It's going to have a list of security group IDs. We don't have any of those made, so we can just leave that as a placeholder for now. And again, if you're doing the console, this would be the step that they ask you for after the instance type and details. And then we have two more fields that we're going to need to make. One's going to be private IP, so private_IP. And we can just set that to an empty, to something empty for now as well. And then key name, key_name. And if you recall, at the very end of the EC2 process, they're always like, what key pair do you want to use? And if you don't use one, you're never going to be able to get into your instance. Well, this is that part as well. And then finally, just tags, which we can actually go ahead and fill in. In fact, it'd probably be easier to just grab it from one of our other things. And while we do that, I'm going to answer a question here. Are there any plans of doing a session with TFC and HCP Packer? Seems like it would help with the AMI things. Whoops. We did talk about collaboration, and that'll be towards the tail end of the series of episodes. And when we get to that, bringing up Terraform Cloud and the different HCP services will definitely be on our radar for there. So, yeah. And anyone looking in terms of tests within Terraform, yes, please reach out to Rosemary. She both knows and loves testing within Terraform. So yes. Yep. So this is looking good. Yep. Perfect.
Okay.
So why don't we go ahead? Let's start with at the top, right? Let's just start with the AMI. So with this, there exists a service, SSM parameter store. So SSM in general. Jenna, would you like to talk about SSM? I can't even for the life of me remember what SSM stands for. I've used it for years.
Yeah. I don't even remember either. I should know that.
I get it mixed up with STS. Like, is that simple token service? Is it security token service? Is this one simple systems manager, or is it like?
Well, now we're going to just Google it. We're not going to Google it. We're going to go to the actual page.
Yeah.
I feel like it's under here, but I could be.
Good luck. I have no idea where this would be. It's okay. There we go. It's under Systems Manager, AWS Systems Manager.
Where do you see that?
Oh, I don't. I'm just looking at a comment in the chat. Yeah.
Oh, got it. Okay. Now we're going to go in here.
Yeah. There it is. That's right. So the name was, so I'm just going to highlight the black mage here that was formerly known as SSM. So that is why. So, there we go. I see it. Parameter store right there. Interestingly enough, we still refer to it as SSM within Terraform. So I guess that's where my confusion is coming from. Well, what we're going to do is we're going to, if you would like to hop over to the docs, the Terraform docs specifically, and let's look up SSM, because that is actually where it'll be entered here. There we go. SSM. So remember, we have resources, which is how we tell AWS to make things. And then we have data sources, which is how we get things. We want to get a parameter. So this is how we do that, right? And when we get that, we need to pass it a name. So what the name is of the parameter we're trying to get. And it's going to return to us a set of attributes, one of those being an argument. Now, the attributes, you don't see them on the side navigation, but if you scroll all the way down, they're actually hidden down there as to what they return. Yeah, I don't know why we didn't add an attributes sub side there, but yeah. Anyhow, the value is what we're actually going to be looking to get. So we can actually just go ahead and copy paste that example and then just sort of change it out.
Okay.
Yeah. So why don't we just throw that into that file? Yep. And the actual, I'm gonna send you, actually, I've got the docs for that here. Here we go. Let me send this over to you. And actually, I'll put it in the chat here as well. But we need to change that name argument that you have to the name of a parameter on AWS. And I just sent a doc over to you to open up that shows public AMI parameters. The thing is in parameter store, you can go and make your own parameters, but AWS has also added a bunch of public ones that you can reference, even if you don't see them like in your console. And one of those sets of parameters are to get versions of the AMIs. And so these are the docs for that. We can obviously peel through them, but I can also just tell you exactly what you would want to put. Up to you, Jenna. Yeah, here we go. If we scroll down, that is the list right there. Okay. Those are, for example, for Amazon Linux, which is what we have been using. These are the various, these are the names of these parameters. And when you call to them, they will give you the latest version of that type of Amazon image. All of these are differentiated by like whether they use HVM. So I can't remember what that stands for. I know PV stands for para-virtualization, but I don't remember what HVM stands for. And then the architecture and then the type of volume in storage it uses. So anywho, I've got the one, I'm not going to sit here and act like I know all of those by heart. Yeah. So instead, I'm going to just send you the one that we're going to be using. Okay. And I'm going to just send it to you right here. Here we go. And this one actually isn't calling to Amazon, an Amazon Linux version. I forgot that we're going to be using Ubuntu, but there is the link that you can put in. Yeah, there we go. And so that's just asking for that name and the name to use this. Go ahead and name that whatever you would like. Okay. Sweet. And then to reference that, we're going to go to that AMI argument on line 6 and delete the double quotes because we don't need those now. And just do forward to reference a data source. We begin with data instead of the actual resource name. And then after that, it's just like how you reference a normal resource. So our AWS SSM parameter, okay, and then the name you gave it. Yep. Yep, and then dot value. That's the only thing we need to add at the end. Yeah. And so this is a nice quick technique if you want to keep just pulling the latest AMI. I will say there's a downside to this. The downside is you're always pulling in the latest AMI. So if you're not careful, you'll in watching and doing a Terraform plan, for example, up front, if that image gets updated, then guess what's going to get updated in your end, right? It's going to update this and it's going to destroy the instance. So just make sure you watch for that. Probably a more stable pattern, probably a better pattern is to lock this down to an actual value. But I just wanted to show, we both just wanted to show an easy way to use the SSM parameter store and just how quick that is, because it's very convenient, right? So cool. So this brings us to the security group IDs then, and this is going to be the security group that we put in front of the database. And for that, what we're going to do for this one, if we want to go over to security groups, we are going to make a security group that does a couple of things. And specifically, it's just going to allow in traffic from anything that has either the fruits service security group or the vegetables service security group. And I believe you've got our pasta there on the other end that we can just drop in for that instead of coding it by hand for the yeah, we can do it by hand, but I mean, again, we've been just sort of pasting the security groups because we don't want to spend too much time on those because they're all straightforward.
So I just copied in or pasted in a few things here. So we've got the actual security group itself in our VPC. We created a rule that allows fruits. A rule that allows vegetables.
Yep.
And then the outbound rule.
Yep. That is it. You can change that on the first thing we just pasted in, the security group itself, to match our tags thing.
Oh, yeah, that's right.
Yeah, just that. But we're going ahead and optimistically creating a security group because we know, we haven't done it yet, I think you need to remove the AWS underscore on that security group as well. Okay, you're already doing that. Because we know we're going to set up this fake service to listen on 27017. So that's why we know that is there. We know up front because that's how we're going to architect it. Okay, so simple enough. Now we just add that security group to the EC2 instance. So it's just going to go in that list there. We can remove the double quotes. And yep.
Oh, wait.
Oh.
That.
Yeah, there we go. Yep. And then .id should do it.
Yep. Okay.
Yeah. Nice.
But what happened if I didn't have ID there? Would it complain when I did the planner apply?
You know, I don't. That's a good question. I mean, I know it would catch it. I just don't know at what point it would catch it. If
we wanted to try that before when we get going.
Yeah, we can do that for sure. Cool. Okay, so private IP and the key name. Now these are both going to be just values that we put in. But the thing is we should probably set up variables here. We can put them straight in, but I wanted to show you another way to use variables and load them in. So let's go and create the variables for a private IP address and key pair name first. And so wherever you'd like to put them, yeah, may as well just at the bottom, I guess. Then we'll make the first variable. Yep. And we'll just call this, what shall we call it? The first one being database private IP. Let's just call it that. Yeah, there we go. Yep. And this is going to be a type string. Yep. And then description, just whatever you want for it. Yep. And then for the, yep, and then you've got it. And then let's just set it to 10.255.3. Actually, let's look at our VPC real quick, because I need to make sure, actually, we can look at it right in the variables because we're setting it here. I just want to make sure, yes, our VPC CIDR block is in the .255 range. Okay, perfect. So .3.255, and we can just, I believe, leave it at just that. Yes. So what we're doing here is we're making some assumptions in terms of where we're putting this thing. We're, instead of allowing the AWS instance to be created and then grabbing the private IP address, we are going ahead and setting this up front. Now, why this is the case will come more into play when we set up and start working with console. But in essence, what needs to happen is we need to go ahead and tell our task definitions about where this database can be reached before it's live. So unfortunately, though, we don't have anything in Terraform to where we, well, not at least with what the tools that we're using right now, to wait on this instance to go and be created and then get that private IP address and bring it back in. I know we could use the private DNS, and maybe we could look at that because that is something an instance returns, but this is more of a thing when we start working with auto scaling groups that create batches of EC2 instances. The only way you can get their IP addresses, public and private, are after they've been created, which we would have to do in a script. So we're doing this here for, I would say, part convenience, but the other part is just the limitation of the way Terraform goes and applies things. So whether or not that's a limitation, those up for argument. Anyhow, so that's the first variable. The second one's going to be for our EC2 key pair. And so we can just go ahead and make that. Which will just, yeah, new variable and just whatever you'd like to call it. Yep. And it's going to have the same arguments for the most part. And while you're doing that, I'm going to just look at something real quick. You look at this. Yeah, that should still work just fine. Yeah. So, right, perfect. And so I'm assuming that's the name of your key pair.
Pretty sure.
Yeah. Yeah.
Yeah.
Yeah.
I
Cool.
created it a while ago, so I'm pretty sure it is. So we'll find out.
Yeah, cool. And so we can set this as a default here, and that's an option. But something else we can do is we can make another file in this directory just called terraform.tfvars. And then, yep, just like that. And then this is going to just take the format of key = value. And so we can literally just rip what you have for the defaults out of there. Just take those defaults. And instead of default, you'll just switch that in the file with the EC2 key pair. Yep. And you don't need double quotes either around it. Yeah. Yep. And then we can just do that again for well, you do need it for that. Sorry. Just for the key, you don't need the double quotes. Yeah.
Oh.
Yeah. And then we can do the same thing for the database IP if you would like, although it really doesn't matter. It's mainly just to show how this works, but. Yep. And what this file does is when you run and apply, if you have a file named terraform.tfvars, it is going to pull these values in and use them as the input variables. And again, it's going to, if you have default set, whatever you have in here is going to override those defaults. But this is a nice place to keep values. Obviously, you can be a little bit more freeform with them because you can see we already have these get ignored. So where this is going to help you is if you're working on a project. It's going to help you in a lot of places, but probably the most immediate place you'll see value from it is just for local development environments, right? Just pulling down stuff, changing around values for yourself without directly modifying the variables.tf file. Okay, cool. So, any thoughts so far, Jenna? You've had to do a lot of typing.
Compared to earlier, I have done more typing. No, this is good. This is good.
Cool.
Yeah.
Yeah. So now we're just going to use those values here. And
I don't even remember what I called it.
All good. I do that. I mean, I think everyone does that though, right?
Yeah. Now, is it just that, or do I have to do like value?
No, you just do that, and that'll pull it in.
And then the other one.
And I also forgot that we forgot to specify the subnet that this is getting deployed into. So we do need to specify the subnet and then it's just another argument, which is subnet _ID. Yep. After that. We just want that private one. So private, and then the syntax, we're going to be specific here. So yeah, 0 and then .id. We're just going to put it in the first one.
Can you remind us, and by us, I mean me, what the 0 is doing? Like, I understand it's like indexing in, but is that saying we want the one subnet from the one availability zone? Yes.
Sorry. Could you sorry. Can I phone a friend?
Okay.
No, I'm kidding. What? Yeah.
So when we use the 0, the brackets and 0, we're getting the first private subnet, right?
Yes.
And it's the first one of the 2 availability zones that we used.
Yes.
Yep. Okay.
That's it.
Okay. I think I
that's
talked
correct.
myself through it.
Yeah. And that is all stemming because we created those using that count meta argument. But we actually need to check something. Would you mind going to our VPC console? Because I need to make sure that the subnet it's getting deployed into matches up with the private IP we're giving it, which it should. And this is part of the problem with, you know, hard coding the IPs here. So we just go to subnets.
Oops.
All good. And then if we just expand that name column so we can see the private ones, because there's the 2 private ones. And if you would scroll over to your left so we can see their IP addresses. Okay, 3.0.24. That's interesting. This should work. We may need to change that to .2.
What can you share a little bit more about what you're looking at?
Yeah.
I'm not following
Apologies.
here.
Yeah. So what's happening is we're deploying the database into one of these private subnets, the first one. My assumption is that the first one should be US East 1A, right? And if we scroll over to US East 1A, so sorry, if you scroll over to the right, we'll see, sorry, too far, to the CIDR blocks. Yeah, we'll see that it's CIDR block on 1A.
I'm sorry, I highlighted the wrong one.
Yeah, all good. There we. I think
This
it's the one right below.
Oh God.
Yeah,
no.
is it is a .2 is 255.2 .0.24.
This one.
Which the .2 after the .255 is the key part, because that means assuming that the US East 1A is the first private subnet we get back, this might not work because we are trying to give it a private IP with a .3 instead of a .2. So just to be safe, I'm going to assume US East 1A comes back first. Why don't we change that private database IP to 255.2 instead of 255.3.25, whatever, under our variables. There we go. And by the way, also, would you change that to 253 at the end instead of 255? Yeah. As to why, if there's someone in AWS that knows a bit more, my understanding is that the tail end of every subnet, the 254 and the 255, are reserved for their DNS servers and some other thing. I don't remember. I know, but I don't remember if that is for all of the VPC, if it's for each individual subnet. But that was the reasoning for that. Okay, cool. Glad we checked that off. Hopefully that doesn't do anything. And going back over to our EC2 thing. Yeah, this all looks pretty good. Okay, cool. So just real quick, we do have a question on any tips doing Terraform for cloud search. Would you just to follow up, if you could, what do you mean by cloud search? I can follow up with that. And then IP hard coding is brittle. Can we use, we can use data, can't we? I'm no expert. Where there is an option that I swear was not there when I looked at this, like, admittedly, probably like last year, but that was grabbing the DNS, the private DNS instead of the private IP. Just to go into why this is the case, a techie thought, and that's a great question. Why are we hard coding the IP? We are doing this because when we get to the console side of things, it is going to be far easier from a bootstrapping perspective if we know where the brains of our cluster exists. Now, in this case, we're going to kind of see this. This will make a little bit more sense when we go to actually use this database, and I'll pause there and we can talk about it a little bit more. But just for time's sake, we should probably move on to making a bootstrap script, because right now this is just going to make an EC2 instance, and that's all it's going to do, right? So we're going to do that with AWS user data. So we can add another field here just called user data, or argument.
Is that one word or an underscore?
Data. Yep, there you go. You got it. Perfect. Just like that. And we can just leave this empty for now. And what we're going to do is we're going to go make a, we're going to, in our folder here, in our root folder here, we're going to make a new folder just called scripts. And you can really call it whatever you want. I've just made it a habit of calling that. Now let's just make a new bash script in there called database.sh. And instead of you having to type out a bunch of awkward bash code, you should have, yeah, there you go, all that stuff.
I'm copying this. At a high level, this is, it's installing our fake service.
Mm-hmm.
It is setting it up so that it accepts traffic on that port.
Yep.
And then starting it.
Mm-hmm. That's exactly it.
Okay.
That's all a script is doing. There's not really much else to it. We're going to modify it here a little bit, but how do we use this script now, right? Well, if we head back over to our EC2.tf, I'm going to send you, actually, you should have some links to some docs. So we're going to need the help of two functions here. One of them is base64 encode, which is going to do exactly what it says it does, actually. Just base64 encode it. But yeah, there we go. I think you're pulling up. And to answer the question while you're pulling those up, just to create a module for AWS Cloud Search that already exists on my, yeah. Maybe you have more context on this, Jenna. By Cloud Search, AWS Cloud Search, is that like a specific service within AWS?
I'm sorry, what was the question? There are search services. I don't believe they're called Cloud Search specifically, so that's why I'm not really sure.
Yeah, I'm also not really sure as well. I think any more specifics that you might have, I might be able to answer a little bit more so. But in terms of creating, are you creating looking to make a module? So just modularizing and making smaller reusable bits of code that you've got up, or are you looking to make a provider like altogether? So a way to connect Terraform to another API. Just when you get a chance, Mr. Adams, just post that in. Okay, so we've looked at functions before. There's not a lot to say about their general usage, but base64 encode is going to base64 encode any string that you pass to it. And we need this because AWS needs user data base64 encoded. So that's the whole point for that. And then the file function is going to just pull in a file. So that's really all it does. So any thoughts on those two things before we use them, Jenna?
Are we using file or template file?
We are going to use file first, and then we're gonna pull
ahead of myself.
Yeah. No, you're right though. We totally headed in that direction.
Okay.
So we'll just do a base64 encode, and then nested. You could put something there, but yeah, we're just going to go right into the next function, and we're going to open up some double quotes. And we're going to use a special variable that is available to you in your Terraform code. So in $ curly braces, we're going to add path.module. And this is what this is saying is that when it goes to grab this file, it's going to go to our root modules directory and then go from there. And now we can know for every time we're going to definitely go to scripts and database. And this is just a way where if you're moving files around or whatever, it doesn't get lost. Okay, so that is nice, and this is how you would do it. And really, we could just leave it like this altogether, but we did want to take a look at using a template file. So making a template script, a boot script that you can customize, because that's something you're going to wind up having to do. And so there is another function that I believe you have the link to, Jenna, just called template file. And again, go ahead.
Yep, I do.
And we'll have all these links up under the recording when they're done. The difference with this one is it is going to take a path, just like the file function, but it's also going to let us pass a map of variables to this. And we'll be able to interpolate those variables into our script so that we can customize it. And this is something you will definitely be doing, and it is terribly helpful. So the problem is we're going to kind of have to make up stuff to customize because, there's not...
Just a very simple example.
Yeah, it's a very simple script. So I think your idea was to just customize the name and the message, right?
Yeah.
Yeah. So to do that, why don't we go make some new variables? And we will just make, one for database service name and one for database service message. And by the way, for those of you that are trucking along with us from the beginning, we are actually approaching the finish line. We're pretty close. And and here we go. Here's your next book idea, Jenna. It's someone wanting a AWS and Terraform recipes, and another one with the CDK and Python. So there you go. Yep. And nice.
What are we gonna call it? What did we call it over here?
Just database.
Database.
Just do the lowercase. I mean, you can do it uppercase, really doesn't matter, but yeah. Okay, cool. So we've got those. We're just using default, so we don't need to go and, you know, do anything else. So back in EC2, let's make a, just without quotes here, let's just make a, just all uppercase, just database, or just call, I guess, database service name, I suppose. You
Is that got it? That's what we're going to use in this file, right?
Yeah. Yep.
Okay.
Yep, and then just an equal sign, and then just point to that variable value. Yep. And then on the new line, no comma, it's the same thing for the message. And this is as simple as interpolating variables into a bash script is, which is nice and useful. All right, so we're almost there. Now we just got to go use these. So next to the environment name variable, just delete the database string. So yeah, there we go. And then just $ curly brace, and then the name, which you named the variable. Yep. And we just got to do the same thing again for the message, but we will leave the single quotes in. Yeah. Now, for those of you looking to use this pattern, at some point, I'm just going to tell you, because you're going to encounter at some point, you're going to actually need to literally use $ and curly braces. And if that becomes the case, the way that you will escape Terraform from thinking you're trying to use a template value is you will just put another $ in front of that. And that's how you'll be able to like reference, say, other bash variables. So yeah, but that is all we need to do there. And this is an example of us using the template file.
Okay.
Yeah.
And we've got this is all set up right then?
Mm-hmm.
Okay.
And then we only have one more thing to do, and that is to modify our fruits and vegetables task definitions to point to this database.
Okay.
Yeah, so for the first one, yeah.
We're going to do this, aren't we?
Mm-hmm, we are. We're going to do the same thing, except instead of pointing to the load balancer, we're going to use the database's private IP.
So this is just so that people can see what I'm doing. This is the fruits task definition.
Nice.
And you said private IP?
Yeah, so it's going to be HTTP, and then that usual format, and then we're going to call to that var.private database IP. And
right. We created that.
Mm-hmm. And this should outline as to why we needed to go ahead and know the private database IP up front. We needed to know it so that we could go ahead and point to it here. Now, that can be added to the vegetable. Yeah. Now, the reason why it's like, well, why couldn't we just get that from the instance through attributes like we've been through some of the other values? Well, that is just because in the docs, there is no way in Terraform. Currently, we don't return the private IP address for an AWS instance, so you can't. I'll be honest, I don't know if that's by design, if that's by limitation, or we just haven't added it, because I do know that at least looking at the docs 2 days ago, we have since added the private DNS, which for all purposes should work here instead of us having to use the variable. But I honestly haven't tried that. It should work, though, if you use it, I would imagine. But the real reason we're going to have to kind of do this, the problem we're solving here is we needed to know where this database is going to live before it's up. That is why we hard coded the IP in this case. We're going to encounter this same problem again later on when we set up the service mesh, where we're going to have to look at hard coding IPs or perhaps grabbing the DNS. But I just wanted to introduce that thought here. But it looks like we're done. Yeah.
Okay.
Yeah, I actually think this is it. This is
Okay.
like it, I think. Yeah.
So I just want to recap on this last chunk that we did. We created our EC2 instance. We grabbed the AMI from Systems Manager so that we don't have to hard code it. And then we, I'm not going to go through each thing, but we did add variables for both private IP, like you just talked about, and the EC2 key pair. And then we created that database script so that we could set the user data to that script. And we obviously just did these variables so that we could show how to use a templated file.
Thank you.
Okay.
Nice. And now we're ready to deploy. Well, plan and then deploy. But
oh boy.
Uh-oh.
Now we have some things to fix. That's okay.
Yeah.
Variables, line 35. Type string. What did I do on variables, line 35?
What did you do?
I have quotes.
Yeah, oh. Okay. I was like, this all looks right. What was going on here? Okay. I mean, you were right. It was literally a string though. So, I mean.
Yeah, exactly. So that's what happens when things aren't set up right. To answer my question earlier. Okay, so task definitions, line 81.
Oh, so is that what we called it?
Has not been declared.
Maybe did we call it database private IP instead?
We probably did. So, okay, 81 and 123. Oops.
Okay, yeah. So on our variables, looks like it was called database private IP instead of private database IP. Good old typos, right? I mean, What would the world be like without those? Sweet. All right, nice.
How it's going.
Yay. Okay. Well, we kind of answered that question you had earlier. Like, is it going to catch?
Exactly.
Yeah. Oh, I didn't know this. There's a tip here that you can command click on the console to go to the exact line of the thing. Oh, I didn't know that. I had not tried that.
Well, I'm going to try that next time.
Yeah. All right. So it looks like we're going to add things, destroy. Oh, we're probably going to destroy those two task definitions since we updated them.
Exactly.
Yeah. And this is going to go forth and conquer. So I guess the thing here is when we're taking this pattern, the sort of the workflow we've sort of set up here and thrown upon Jenna is that anytime we want to add a new service, anytime we want to add anything, she's going to have to come back into our code here and sort of manually set it up. And there's obviously ways we can make it easier just staying in this architecture. But I guess before we move on to the larger topic of like service mesh and things like that, is that when you're hooking up services outside of, let's say, containers, in this case, outside of our ECS cluster, there's not like some magic solution to it. You still got to go in, you still got to be very specific about where things are. It looks like we've got a key pair thing.
I'll make that while you keep talking.
Yeah. Do you want me to unshare your screen while you look it up? Although I don't think it.
I mean, yeah, let's do that. I don't know what I'm looking at. I mean, we'll see what I'm looking
all good. I guess the whole thing is when I've got into connecting a variety of services, you come into this concept that things are just going to magically come together, that there's some setting or flag you're going to put and it's just going to connect all things. But as you saw, connecting that external VM to these containerized services required some manual setup. Well, pretty much all manual. We had to define an IP. We had to link our services to that IP. And the problem with that is that if this database changes, if the IP changes, if we need to change other things, there's a lot of work we're going to have to go back in and do to keep those things all set in place, which is what we're going to hopefully try and show is solved when we head over to the service mesh aspect. But yes. But if all things go well, it should still work as in such a fashion where our client and all of our services don't care where that service is being hosted. They just care that it's returning what it should be returning. So.
Okay. I spelled it wrong.
Yay.
Sort of. So now does that?
Do you want me to reshare your screen? No.
Yeah, sure. Yes, please.
Cool.
We'll find out if this works. I'm curious on if that PEM file has to be in a certain location.
It should be it should just be the name, in the sense that it's going to assume that it's going to look on AWS for it versus like your local machine. So
okay,
looks like it made it through though. Nice.
Yeah. Oh yeah,
yeah.
it's just setting up the instance with it. That's right.
Yeah. Would you like to plug the survey again, perhaps, while we wait for this?
I would. Okay. As you know, we like to make sure that we are giving you a good experience here, and so we would love to have your feedback using this survey. Specifically, we look for feedback on how the show is going, what you would like to see us talk more about or less about. Constructive feedback is always helpful. And then also, if, for instance, you have feedback on some of the services we're using, we are here to be able to pass that back to service teams and help them build services in a way that are most useful and most valuable to you. So if there's something that a new feature that you're looking for, that type of thing, or something's not working the way you'd like it to, you can also put that feedback in there as well. I mentioned this earlier, the first 20 people, I don't know where we're at right now, but the first 20 people that take the survey, we're over 20 people, so you won't get it. But that took the survey should have gotten an AWS credit, $25 credit. And again, as we mentioned with the one person who ran into this, if you got it during the last episode, you would not get it this time. I'll see if I can fix that for the next episode.
I'm just posting that survey link again into all of the different chat channels. Cool.
Yes. Yeah. Okay, let's take a look at where we're at. So we've got success.
Nice.
Should we go in to
let's check it out. Now I hope this works, but it worked a lot faster than I expected. I don't think I think it's still, if it was erroring, it would at least show us that. So it may just still be draining. Yeah, because it's got 5 tasks running. So so it's probably still, if we click into the vegetables one, perhaps. Just see where it is on this, just under the tasks tab. Okay, so it looks like this one may be updated. So let's see. Come on, thing.
What is it we're looking for here?
All of those should have another upstream calls field, and
right.
They should be going to the database.
Okay.
Perhaps hard refresh, maybe. A Command Shift R, maybe that'll do it.
seem to do more.
No, it's still the same thing.
It is the same.
Let's go back to our ECS thing here, and you know what? Let's. I want to make sure for sure it is not a certain thing. Can we go to the EC2 console?
Yeah.
And then take a look at our database under the instances tab.
There we go.
Yeah. Okay, there we go. That's it's the only one. Let's click on that. I just want to see what IP or what subnet it got deployed in. So that's correct. Will you click on the subnet ID? Just it'll take us to it. And then look at its CIDR block. Okay, so that shouldn't be that issue I brought up. That shouldn't be it. So it isn't the right one with the right IP. So it could just be that it's still going up. So perhaps let's give it another refresh. Let's go to the UI. Maybe that'll. Okay, we're still not connecting back. Let's go to the ECS thing. This will be a little debug thing. Back to the ECS console. That is, perhaps one of the tasks is failing. It's still running 5. So let's go back into the cluster, and then into the vegetables tasks. We'll just start with that one.
Into this?
Yeah, sorry, here? That one right there, and then into the tasks thing itself. And then scroll down and click on stopped, the stopped bit under task status. So we've got 2 stopped. Will you expand that task definition? Okay, it looks like the second one's live. Will you click on the task definition link up top? Well, you can click on it down there as well. I just want to see what it looks like if you open that in a new tab. Yeah. And then just click on the JSON thing. And then I want to see the environment variables here. Okay, that should be doing it, or did we need to specify? You know what we may have needed to do? I know what we did. We need to add, okay, apologies. What we need to add is do you see on the upstream URIs for both of those? We need to add the port number.
Oh,
so, yeah.
Sure.
Yeah,
okay.
We need the :27017. Whoops.
That's okay.
Yeah, that's a quick fix. Techie thought, yeah, everything should be HTTPS. We don't have that set up right now. And we don't have it set up in anything, so I'm not going to try and make an excuse. But that's just, we talked about at the beginning to get that all set up. And I love using AWS Certificate Manager. The cleanest way it would just be especially for a public-facing load balancer, is for us to have a domain name, and we don't. So just after that, yeah, just 20:27017. And there we go. We planned to do a debugging session, didn't we?
Yeah.
Yeah, there we go. So, well, at least it was simple. At least it wasn't some weird thing neither of us had seen.
Exactly. Or that we couldn't figure out.
Okay. It is. Okay.
I didn't do a plan, so we're just gonna go for it.
It'll show us that.
I know.
Up front, yeah. So we'll be good. There we go. So it's gonna replace those 2, and we good. And we'll need to wait for those to all warm up again, which shouldn't take too long. But yeah, so I guess while we're waiting for that, because that will take a couple. What we can go ahead and do is run that awesome Terraform format command to format all of our code. So FMT.
Okay, I'm gonna do one thing first.
Good idea.
I like to do all independent things in each of my commits. That's just how I like to work. So I'm gonna.
I'm smart.
do this commit first. And then we can do that.
It's a good idea.
Is it format
See,
or
even good
FMT?
Git practices. Go ahead. Sorry.
Is it format or FMT?
It's just FMT.
Is FMT.
Yeah, we want to make it ambiguous, and so that when you see FMT, you don't know what we're talking about.
Yeah. And I also, part of the reason why I wanted to do that is I wanted to show what this is doing. So
good
when
idea.
I was typing stuff out, I just straight up typed it, right?
Yep.
But now this is aligning things very nicely so that it's a little bit more readable to people. Mm-hmm. There's probably more that it does, but that was just kind of one of the things that I noticed.
That's all it does. So yeah, but it should do it to all those files, so it makes it nice and scannable. Cool. But yeah. Okay, so how does our go ahead and do that, and then we'll take a look at stuff.
Well, I'm not going to wait to push it until we actually know it's working.
Good point.
Okay, and then this.
Come on. Do it. Oh, we may need to. It may still be spinning its wheels. Oh, wait. I think it's doing it, maybe.
Oh. No.
Let's take a look at the ECS console. Oh, it is doing it.
Look at it. It is working.
Maybe it must have just happened. It literally must have just happened. Okay, nice. So here we have those all working, and the database is there. Can we check the payload one more time? Like, hopefully that actually.
Yeah, I think that's a great idea.
There we go.
Now we see it. Now we see the client upstream calls, and then the upstream calls to the database.
Yes.
Hello from the database.
Yay.
Hello from the database. Cool.
Great. So here we are at the coming close to the end. Would you like to do a recap, Jenna, of all the incredible code you've created?
Yeah. So we started today with where we had ended 2 weeks ago, which was 2 weeks ago we ended with that client service, and then we wanted to extend it today by putting those 2 private services, the fruits and the vegetables, in there along with that database service. The database, again, we're just using fake service. We're not actually spinning up a database, but we just wanted to be able to show you how, as part of this whole thing, we have not just containerized services, but we also have external services too. So in this case, it's just an EC2 instance with fake service running on it. It could be an RDS database. It could be something totally different too. So just keep that in mind. It's just for the demonstration purposes. There are a few Terraform things that we touched on today. I think the base and code 64 and the template file were 2 new concepts that we looked at. We looked at obviously the resource type for AWS instance or EC2 instance. That was a new one for us. What else am I missing? I think that was pretty much it.
Yeah, I mean, from a higher level.
We also talked about using Systems Manager to get that parameter for our AMI. And that is just it's a way for us to make it more dynamic rather than hard coding it into our code.
Yeah. Nice. Well, that is in a nutshell, and this brings us to a close of this chapter 1, whereby we've set this thing up without service mesh. And I do. This is just of my opinion. My opinions are my own, But I know that I've encountered some folks who are building smaller scale applications, right? Ones that are just multi-tiered with maybe a couple extra services added on. And the question is, they'll reach this type of point and they'll say, well, should I add like all these other things? And I just want to say, if it's working right now and it's hitting the scale you need, maybe one day do it. But this pattern, if you can think about it simply, if it achieves your needs, then start thinking about why you want to change. Like, do you want to change because there's a trend going on, or because it will actually help your use case? So I wonder, what are your thoughts on that, Jenna? Like, in terms of like saying using like the biggest things like from the get-go versus, what do you think?
So I'm a very pragmatic person when it comes to writing my code. And there's lots of schools of thought on microservices and whether you should use them or not, and when to use them. And my and when you introduce other technologies like a service mesh, or this API gateway that we talked about earlier, I'm very much of the mindset of do the minimal amount of thing that you need right now, in a way that's scalable for the future. And so right now, like, if I'm just the only developer on this project and I've got 3 services, or maybe I've even got 10 services, I probably don't need it yet. But if we've got hundreds of services and more than just me and my team, then that's when I need to start thinking about, how do I simplify our workflows? How do I simplify the code and the complexity there, so that we can scale this, both scaling our infrastructure, but also scaling our team as well.
Yeah, that's exactly my thoughts on it as well. I suppose that I will sometimes like hear like, well, why did this small team go ahead and do it? Why are they able, like, why are you, Cole, for example, why are you and Jenna already using like parameter store and doing some of these things?
Yeah.
Well, it's a good question, but the truth of the matter is that if you have the experience already under your belt, to go back with what Jenna said, creating a foundation for scaling for later. If you already know you're going to wind up there, that's a little bit more reason to go ahead and add those things up front. So, but yeah, what Jenna said was on point. So that said, let's assume we are heading at that larger scale. You know, what are some of the problems that you see with our setup right now, Jenna?
Yeah, I mean, so one of the things, we touched on, as we were going through this is, there's a lot of like common code. So that's kind of one thing that I look at. Another thing is the developer experience. Like, as a developer, I don't want huge files that I have to sift through and try to understand, especially if I'm not the one who's writing all of it. So one of the benefits of writing these very small independent services, in this way, is that I as a developer can focus just on this one. I can understand the business behind it. I can understand the technology behind it. I can write it in my own language, or a specific language that I'm familiar with or that my team is familiar with. And then we can have these other ones that are all independent, and they can all be maintained and released independently as well. So yeah, the developer experience, I think, is also a really big one, that I'm interested in understanding a little bit better. And then also, and this is no surprise, because this is, what we've been talking about and where we're going, is when you have all these services and they have to talk to each other, like, how do you manage that? Like, it's hard enough to manage it in code, but then you have to like understand it in your head too, to make sure that what you're expecting is going to happen is actually happening, and so that you can actually write code in there as well. And so, yeah, so those, I think that was three big things that I mentioned. That's kind of what I've been thinking about as we've been building this out.
Yeah, for sure. So it sounded like developer experience is definitely one thing. Workflow in terms of file size, file separation of concerns, and then the last one sounds like sort of operational overhead, right? Extra stuff you got to do. And we saw that as Jenna added that third service. Like every time we're going to add service, she's got to go back and modify client. She's got to go back and tweak things in all the existing ones to let them know this new service exists. And while that works just fine, it does create that ticket-based workflow, right? And it leaves human error or room for human error, which is guaranteed, right? Yeah, exactly. So why were it moved to a service mesh? Well, moving to a service mesh is going to help us deal with some of those problems. One of the immediate things you'll see from an operational overhead is we will see a lot of these load balancers go away, right? That'll make things a little bit easier. I mean, not entirely, but we're still going to need them. You're always going to need load balancers here and there, but we're going to see the overhead of trying to remember what services should go where and tweaking those settings. We're going to make it so that all kind of goes away and we just have one unified area that serves as the brain to tell all services about all services. So that's something that it's going to help with. Now, since we've run a little long today, we were going to try and intro a service mesh and the stuff that it does. But I do think, Jenna, what do you think? Do you want to just save that for the next
I think we should save that for the next time. Just let that be a little carrot for the next time.
Yeah. So that's something you can do beforehand. Just what are the problems that you think you'll encounter as someone viewing this with this particular architecture moving forward? Whatever those are, as you grow your microservices, I'm going to just sort of throw it out there. A service mesh is probably going to be a potential answer to those questions and problems. So
yeah, I think, for those of you who will be with us in 2 weeks for the next show, start thinking about that. And maybe that's a good question for us to ask at the beginning is like, kind of like Cole just asked me, like, what are some of these challenges that you see or foresee happening? I'm interested in hearing what you have to say. You can certainly put it in the chat right now, but save it for the next show too, so that we've got a little bit more to talk about there.
Oh. Awesome. And just as a spoiler alert, we will be using console. So that will be what we'll look into.
Yeah.
So how about one more plug on that survey?
Yeah. Again, your feedback is very much welcome. We have a number of surveys that have come in already, so it's very helpful for us as we shape the rest of the show and any future work that we do either independently or together. It's really helpful to make sure that we're getting you what you need. And again, like any product or service feedback that you put in there, we'll make sure that the service teams get that into their queues as well. I think that's all I have as far as the survey.
All right. Well, that brings us to the close of part 1 of our series. We've got a microservices architecture on AWS. Right now, we're going to be looking at different flavors. Thank you so much for everyone that has been viewing and following along. Thank you, Jenna, for all that you've done and for coding live.
Yeah,
which is always
thank
fun.
you everyone who has asked really amazing questions and caught our typos and stuff like that, and helped answer other questions. That's super helpful for us, and it makes like staring at this camera a lot more fun than if I was just staring at the camera and there was no one there. So thank you.
Yes, thank you very much. All right, so as we've said, this will all be up on YouTube, hopefully end of day, if not tomorrow morning. It'll be live immediately, but in terms of having all of our chapter markers, all of the resources up, there will be a little bit of a lag there, but that's all I've got. Any last hurrahs, Jenna?
I think that's all I've got too. Thank you all so much for joining us today.
All right, thank you. Till next time.
All right, bye-bye.